You know that tech that's so good at picking your next favorite movie? Well, what if I told you it's also helping doctors diagnose diseases? Yep, that's the power of machine learning, and today we're going to break down exactly how it all works.
So how can one technology do so many completely different things? Well, it all comes down to the way machines learn. And honestly, it's way more intuitive than you might think.
Okay, let's try a quick puzzle. Just look at this. If x is 1 and y is 1, then x is 2 and y is 4. You see where this is going, right? What do you think y is when x is 4? And hey, before you even say the answer out loud, your brain is already doing something that's, well, it's remarkably similar to a machine learning model.
Yep, of course, it's 16. You instantly spotted the pattern, right? Y is just x multiplied by itself, x squared. You didn't need a rule book or anything. You learned from the examples. And what your brain just did, almost instantly, is the core of machine learning. It's really just these three simple steps. First, you observe the past data, those pairs of x and y. Then you found the pattern that connects them. And finally, use that pattern to make a prediction for something new.
And that, right there, is the whole idea. See, machine learning isn't about programming a computer with a rule for every single possible situation. No way. It's about teaching it how to learn from data, so it can start making its own smart decisions.
Okay, so now that we've got the basic process down, let's check out the two main ways machines actually learn. You can think of them as two totally different styles of teaching.
So on one side, you've got supervised learning. This is kind of like studying for a test when you have the complete answer key. The machine gets to see the questions and the right answers, and it just learns to connect the dots. But then, on the other side, there's unsupervised learning. This is more like being handed a giant messy box of Legos and someone just says, "Go build something cool." There are no instructions. It has to find the interesting patterns and structures all by itself.
So what can you actually do with this answer key method? Well, supervised learning basically splits into two big jobs. The first is classification. This is for predicting a category. You know, is this email spam or not? Is this visa application going to be approved or denied? But what if you need to predict an actual number? Well, that's where regression comes in. It's for forecasting things like next quarter's sales or the price of a house.
Unsupervised learning, though, that's where the real discovery happens. Think about a streaming service. It could use this to sift through millions of people's viewing habits and automatically find hidden groups, like late-night horror fans or people who only watch documentaries. It creates these new recommendation categories they probably never would have even thought of on their own.
Right, so these different ways of learning, they aren't just ideas in a textbook. They are running all around us, all the time, often in ways you probably don't even realize.
I mean, think about it. When your bank flags a transaction as maybe being fraud, that's machine learning. When your map app tells you your ETA through all that traffic, yep, machine learning again. It's analyzing player performance in sports like the IPL, it's helping airlines figure out ticket prices, and it's even shortlisting resumes for jobs. It is truly the invisible engine driving so many decisions in our world.
The impact here is so huge that, get this, over a decade ago, Harvard Business Review was already calling data scientist the sexiest job of the 21st century. I mean, the sexiest job? That just tells you how critical this skill set had become, even way back then.
Okay, but this brings up a really important question. Right now, we've got these incredibly powerful pre-built AI tools like ChatGPT. So, does all this foundational stuff still even matter? Well, let's think about it with a simple analogy, using cars.
So let's start with the most hands-on role. Imagine you're someone who builds a machine learning model completely from scratch. You're writing the algorithms, prepping the data, training the whole thing yourself. You're playing a very specific part in this ecosystem.
You are the car manufacturer. You are building the entire vehicle from the ground up. The engine, the chassis, every little piece. And that obviously requires some really deep, specialized engineering knowledge.
But let's be real. Most of us are not building AI models from scratch. We're using tools like ChatGPT or those cool image generators for our work, for our daily tasks.
In that case, you're not the manufacturer at all. You're the car driver. You don't really need to understand the complex mechanics of the engine, right? You just need to know how to drive the car well to get where you want to go. And in the AI world, that's all about writing good prompts.
But then there's this really fascinating middle ground. What if you want to take one of these powerful, pre-built AI models and tweak it, adapt it for a very specific custom job? Well, that makes you a car tuner. You're taking a high-performance car that's already built and fine-tuning its engine for a specific racetrack.
Maybe you need a little more speed on the straightaways or better handling in the corners. You didn't build the car, but you absolutely need to know enough about how it works to modify it effectively.
Okay, so if most of us are just going to be car drivers, just using these powerful tools, why should we even bother learning about the engine? The machine learning fundamentals. Is that knowledge just for the experts, the manufacturers?
The answer to that is a huge, resounding no. Because think about it. While pretty much anyone can learn to drive the car, to become a truly great driver or a great innovator, you eventually need to have some idea of what's happening under the hood. See, this foundational knowledge, it gives you power. It's what lets you troubleshoot when things go wrong instead of just getting stuck. It lets you fine-tune these models for your unique challenges. And, I think most importantly, it lets you innovate beyond what the tool was even designed for in the first place.
And here's what's really exciting about all this. As we all get better at understanding this engine, the way we actually interact with these machines is changing. The barrier to entry isn't years of learning complex code anymore. The main skill is becoming our ability to communicate what we want clearly and precisely, just using natural language. And this brings us to our final, and maybe the most important thought here. As AI gets more and more brilliant at doing the tasks we give it, our most critical human skill is going to shift. It's not going to be about doing the work ourselves. It's going to be about asking the right questions in the first place. So the real question isn't just what can AI do? It's what are the most important problems we can solve with it? And that's the challenge and the huge opportunity for all of us.